By bringing together partners from 8 different European countries to work on a revolutionary idea, the Sprint project helps turn Europe into the best place in the world for collaborative and responsible research.
The main objective is to provide a new technology that will enable the ultimate control of the deposition of thin films. As you know, thin films are very important for many different applications like microelectronics, photovoltaics, fuel cells, or biotechnology.
The main objective of Sprint project is to develop a universal deposition technique that allows the deposition of virtually any material on virtually any substrate at room temperature and atmospheric pressure.
There is an old quotation coming from the first era of the electronic industry that says that any new improvement has to do the job better, cheaper, or both.
One of the main advantages of this technology would be exactly that you avoid the use of solvents, some of which are being banned by the EU regulations. And another main advantage, in my opinion, is that the fabrication will be digital. And this means that you can iterate much faster through designs and avoid the long and slow iteration cycles we were used to.
Currently, about 90% of photovoltaic industry is based on polycrystalline silicon, which has an efficiency of about 22%. And gallium arsenide photovoltaics, for instance, have an efficiency of 46%, but they are so expensive that they are basically used only in space technologies. Sprint changes that, because with Sprint, we will have high-performance photovoltaics at drastically reduced cost.
Well, for me personally, the power of Sprint is the very different branches of science it brings together.
We are responsible for the modeling and optimization of the microscale gas nozzles. We will use numerical simulation to find ways to improve the performance of the system so that we can ensure optimal depositions at the end.
Our contribution is to combine bio-macromolecules with nanomaterials, and thus we are going to design, optimize and test the functional properties of those new composites.
So I will work on bringing a new type of materials called metal organic frameworks closer to application.
What I bring to a Spring project is my expertise in the deposition of materials by chemical vapor methods, the chemistry of materials, and also applications in the photovoltaics industry.
Our contribution from the Spanish National Research Council will be related to the use of lasers coupled to the spatial atomic layer deposition method in order to control crystallinity and morphology and microstructure in the resultant materials deposited.
In Sprint, CETRI will develop the final system by integrating the different technologies to be developed by other partners. So we are going to deliver the final printer and hopefully see other people working with our machines for new research activities and finally to the industry.
Spring will impact microelectronics, energy production, sensing and biotechnology, and those are very relevant industries for our social and technological progress.
But I believe we will have other sectors also impacted by the technology because they will benefit from the ability to control the properties of the films at very low cost.
Sprint technology is improving citizens' quality of life. For example, we are producing low-cost and high-performance devices, like for example, therapy devices.
The Sprint project will make a very important contribution in the sense that it opens up the integration of European industry into what is called Industry 4.0, the Internet of Things, and this will be essential for the future economies.
By supporting key enabling technologies such as the microelectronic industries, photovoltaics and fuel cells, as well as healthcare biotech industry, the Sprint project contributes to job creation and economic growth, as well as many other tangible benefits for the society.
A project like the Sprint is definitely worthwhile for the European taxpayer because we create knowledge that is patentable, which is going to lead to new technologies, which in the long run are going to create new jobs.